Welcome to episode 113, Spotlight Boundary Protection, focusing on Control SC-7. Boundaries are the structural defenses that confine attacker movement and preserve order across complex networks. They define where one trust zone ends and another begins, enforcing separation that limits damage when compromise occurs. Without boundaries, a single foothold can sprawl unchecked across the enterprise. With them, each zone acts like a watertight compartment, containing disruption before it spreads. Boundary protection is not just about firewalls and routers. It is the discipline of intentional design, ensuring that access follows purpose rather than convenience. Building from that premise, effective boundaries start with clearly defined zones, trust levels, and interfaces. Zones group systems with similar sensitivity or function, such as public web servers, internal applications, and restricted management systems. Each carries a defined trust level based on who or what is permitted to connect. Interfaces mark the controlled crossings between zones. For example, a demilitarized zone may separate external traffic from internal databases, with precise gateways mediating flow. Mapping zones and interfaces makes network architecture visible and governable. When trust boundaries are explicit, control policies become measurable rather than assumed, transforming complexity into clarity. From there, boundaries enforce a default deny posture between dissimilar zones. Default deny means no communication is allowed unless explicitly authorized by rule. This principle prevents accidental exposure and ensures that new services must pass intentional review before operation. For example, a development subnet should not automatically reach production systems unless policy allows it. Default deny simplifies thinking. What is not permitted is blocked by design. It also limits blast radius, containing intrusion attempts before they propagate. The quiet power of default deny is predictability. Every connection seen is one that someone deliberately approved. Ingress and egress policies then add precision by defining exactly what can enter and exit each zone. Ingress rules control incoming data, such as requests from external users, while egress rules govern outbound traffic to prevent data leakage or command and control communication. Effective egress control is often overlooked, yet it is vital for detecting compromise. For instance, restricting outbound connections to approved domains stops malware from calling home. Both ingress and egress rules should specify source, destination, protocol, and port, leaving no ambiguity. Specificity reduces risk and improves troubleshooting, proving that control and clarity coexist comfortably. Application-aware filtering and secure gateways extend traditional boundary defenses. Modern firewalls and proxies inspect traffic beyond simple port and protocol, understanding the application layer itself. They can distinguish a web session from a tunneling attempt, or detect suspicious patterns in encrypted flows. Application gateways, such as secure web or mail proxies, provide deep inspection and policy enforcement tailored to the content type. For example, a web gateway can block file uploads containing sensitive data or prevent downloads of known malware. These intelligent boundaries adapt to user behavior, ensuring policies remain effective even as network traffic evolves beyond predictable signatures. Beyond general web and application traffic, specialized controls protect core channels like domain name system, email, and web egress. DNS filtering blocks queries to malicious domains or command and control servers. Email gateways scan attachments and links, neutralizing phishing attempts before they reach users. Web proxies enforce acceptable use and scan for active threats. For example, combining these controls stops an attacker's common path, malicious email, leading to infected sites and outbound beacons. Protecting these essential protocols turns ordinary infrastructure into active defense layers, converting daily communication into a controlled, monitored, and trustworthy channel. Remote access must always traverse inspected brokers rather than connecting directly to internal zones. Brokers such as virtual private network concentrators, secure access gateways, or zero-trust access platforms authenticate users, inspect sessions, and enforce policy. For instance, a contractor accessing administrative tools must authenticate through a monitored gateway with session logging enabled. Direct connections bypassing inspection create invisible risk. By routing all remote sessions through controlled brokers, organizations maintain both security and visibility. Remote work becomes safe not through blind trust, but through verified inspection and minimal privilege at every connection point. Machine-to-machine communication requires equal rigor, ensuring that automated pathways authenticate and encrypt just like human users. Service accounts, application programming interfaces, and integration pipelines must all verify identity before exchanging data. Mutual authentication, both sides confirming each other, prevents spoofing or unauthorized access between systems. For example, an analytics service pulling data from a transactional database should use unique keys and encrypted channels, never shared credentials. Machine trust must be explicit and logged. Without verification, automation can become an unseen highway for intrusion. Boundary protection extends to every digital handshake, whether human or mechanical. Detection mechanisms then monitor for lateral movement and beaconing that indicate boundary compromise. Lateral movement describes attackers navigating from one internal system to another. Beaconing refers to stealthy outbound communication to command servers. Network monitoring tools and intrusion detection systems observe flows for abnormal patterns, unexpected protocols, unusual volumes, or repetitive outbound pings. For example, detecting periodic connections from a workstation to an obscure foreign host may signal hidden malware. Early detection relies on recognizing deviation from normal behavior. Boundaries that only block are static. Boundaries that also detect become intelligent guardians of the network's integrity. Validation of routes, network address translations, and peering arrangements ensures boundaries remain trustworthy as infrastructure changes. Over time, mergers, cloud migrations, or provider adjustments can alter connectivity. Regular validation confirms that routing tables, NAT rules, and peer connections reflect intended paths and exclude shadow routes. For instance, verifying that all internet traffic exits through monitored gateways prevents data from slipping through unlogged channels. Documentation and approval for every route change preserve governance and traceability. Continuous validation keeps the boundary aligned with its original intent. No silent detours, no unapproved shortcuts, no invisible leaks. Evidence then anchors accountability through documented rule sets, approvals, and configuration samples. Security teams should maintain version-controlled records of firewall rules, policy updates, and associated approvals. Sampling verifies that implemented rules match documented intent. For example, quarterly audits may review a subset of rules to confirm necessity and consistency with design. Evidence demonstrates compliance with policy and readiness for inspection. It transforms boundaries from invisible code into verifiable control. Keeping this documentation current also simplifies troubleshooting, proving that every permitted flow has purpose and oversight behind it. Exceptions, when absolutely necessary, must be tracked with expiration dates and subjected to periodic audits. Temporary allowances, perhaps for testing or migration, should include justification, approval, and scheduled review. Without expiration, exceptions become silent vulnerabilities. For example, a temporary open port for diagnostics should close automatically after the task ends. Audit reviews confirm that exceptions remain relevant or can be retired. Managing them transparently balances agility with discipline. Boundaries may flex when needed, but they should never lose their defined shape. Exceptions documented and expired on schedule show that adaptability and control can coexist. Metrics provide feedback by measuring blocked attempts, policy hygiene, and review frequency. Blocked attempts reveal threat activity and the boundary's effectiveness in thwarting it. Policy hygiene measures how many redundant or obsolete rules are removed during reviews, indicating discipline in maintenance. Frequent review cycles demonstrate vigilance. For example, tracking that 80% of firewall rules were validated in the last quarter shows operational health. Metrics convert boundary protection from static configuration into a living process with measurable quality. When data shows cleanliness and responsiveness, boundaries cease being barriers. They become managed, evolving instruments of assurance. In conclusion, Control SC-7 emphasizes that boundaries should always reflect intent. Properly designed, they embody trust decisions made consciously, not inherited by accident. Boundaries translate architecture into protection, guiding how information moves and how threats are stopped.
They mark the line between exposure and resilience, between chaos and order. In the end, well-governed boundaries do more than block. They clarify, detect, and adapt, ensuring that every connection serves a purpose and every pathway honors the principle of deliberate trust.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.